Bismillahirrahmanirrahim. Saturday हमने एक क्विक रिव्यू किया है कल कुछ क्रिटिकल सर्किट था और उसी का एक अप्रोक्सीमेट वर्जन दोनों को कंपेयर कर लेते हैं दैट्स तो मेक ए कॉपी ऑफ इट launch then we go to the model. Okay, as you can see, these two models. One is called the complete model, and the other is called the approximate. Differences में देख लीजिए, we just remove this and just because of its negligible effect. So this HIE comes here, so this will become the approximate. Now we see one example based on the approximate model. It also reduces one parameter. Okay, in this example, first we understand the example. Okay, so the given parameters, IE is given, HF is given, which is beta. HO is given, we know that R is equal to 1 over HO. The two parameters are given, and also we also know that the RE value. So the RE value is equal to, it is written here, RE value is 26 millivolt divided by IE. So we put the value, we get the value of RE, and HI is equal to beta R. This is another formula which we use to get the input resistance, and this formula use here to get the output resistance. So it is clear that we have the required parameters. We just can draw the circuit. So HI will come here. This HI is this value, and R out will come here. That R out is the 50 kilo ohms. Okay. Then beta is 140. So beta comes from here, beta 140 and IB at the current time because the current is not given here. Right. So this way we can compute uh, the common emitter hybrid equivalent circuit. Let's see किताब में इसको कैसे बताएंगे. This is one important question. Okay, as expected, we have HI, the input resistance, and the output resistance. Here, this is R0, and this is primarily beta RE. And we know that beta is here. If IB is given, let's say the IB is given, we approximate, let's say, microamperes. Microamperes are any instance of time, then we can find that here 140 multiplied with 2. Obviously, AC its value is changing, and similarly, this value is also changing. So this is a better view that how we can primarily. Similarly, for common base, but we are not interested in common base. We are moving towards the next example, which is related with the fixed bias. So in the fixed bias configuration, we remember this circuit, BJT analysis, AC analysis. Now we just need to replace the transistor with the equivalent circuit. So a closer look can see the same model is placed over here along with the resistance B and resistance C by drawing. Okay, हम इसी सर्किट को जब ड्रॉ करते हैं तो C जो है सोर्स उनको काउंट कर देते हैं और इस तरीके से हम जो कैपेसिटर्स हैं उनको शॉर्ट सर्किट कर देते हैं. So if we can see from the input side, Z input is primarily RB resistance in parallel HI. So RB resistance parallel to HI, which is the input resistance of the transistor model. And similarly, if we see from the outside, we get the output impedance. From the circuit is RC. R0. Remember, R0 is primarily this value, which is equal to 1 over H0. So this is the way how the circuit will work. Let's see the numerical. Okay, this is the example. For the network, given network, find the impedances and the voltage given. So as you can see, this is a fixed bias circuit, and many of the parameters are given. So these parameters are given from the data sheet. As you can see, we can calculate the input resistance, H input. We have the value of beta. This is beta. This value can calculate R0 is equal to 1 over H0. So afterwards, we make it parallel with RC to find the output impedance and the input resistance. resistance parallel with input is 30 ohms to find the input impedance. So for input impedance, we have to calculate the RB, which is 330K. In parallel with the input, H input, which is 1.175. And similarly, the output impedance, which is equal to RC 2.7 parallel with 1 over H0. So 1 over H0 is 1 over 20 micro. Micro means 10 to power minus 6. So we can write 10 to power 6 divided by 20. So 0 with 5. So we have 100. 1 with 5 zeros. So it is 53. R0 is 53, so we write it 53. Because it is, if we multiply this value with 10, then this value is less than 50. So we can write Z out is approximately RC as per the condition. So we get the add on to the 2.7 value. And because this value is very high, so we get the same value using another function. Similarly, we can find the, because the input voltage is given, we can find the output voltage. And after finding the output voltage, we can get the area. So the input voltage divided by the output voltage. Let's see. इसमें जब इसको सॉल्व किया है तो इसके आंसर क्या है? Okay, so the input impedance is 1.7, 1.17. Approximately this value is same because this is a higher value. So because this is a very big value as compared to this, we know the parallel, the smaller value will be as well. So R0, as we have also found 50K, approximately that out give us approximately equal to RC. That's 10 times higher. This value is 10 times higher than this value. So we can find this. The formula for AB. We can apply the formula for AB. The main formula. And HFERC parallel with R0 divided by the H input. So after putting the values, we get a value which is negative and also give the gain. Similarly, the current gain is primarily the beta, which is given in the data sheet as 120. So this is how we have this exercise. This is also an important example. The final example today is related with the voltage divider configuration, and this let's see the circuit. This is the circuit. It's a general circuit. We can see its equivalent model, or we can draw the equivalent model in which R1 is parallel with R2 and then it is parallel with the R input. Because RE gone, because जब हम इसका AC equivalent बनाएंगे तो ये शॉर्ट सर्किट हो जाएगा, ये कैंसिल हो जाएगा. Then there is also another configuration in which we consider RE and we primarily remove C. So there is also another configuration. It's like this. That side. Try to be only drawing this part RE part. So there is capacitance network RE. Let's say this is RE1. This is RE2. So when we draw the AC circuit, this is bypass. This is primarily short circuit. And we draw the circuit and you see that this on the. So this is some sort of advanced questions or advanced numerical problems which we can see here. So these are the formulas which we use. As you can see, the input impedance is the parallel of the input side resistances. Output resistance is RC. And similarly, we have the formula for the gain and formula for the current. So we use these formulas to find the output. So we are not interested in common base configuration and similarly common collector configurations, but our primary aim is to understand the common emitter configuration and configurations which are based on the common emitter circuits. Now this is the final diagram of today's session, and as you can see, usually we have a load attached to a system and we have a source attached to the system. So because these two things are present, we have to consider the effect of the source resistance as well as the load resistance. But a general analysis, that means the analysis which we have done in this session and in earlier section, does not consider the effect of RS and RL. When we incorporate RL and RS, then there is other resistances which become parallel to the system, and the effect is recalculated. So this completes our today's session. इंशाल्लाह नेक्स्ट हमारी क्लास होगी उसमें हम पाई मॉडल देखेंगे. पाई मॉडल is our last topic. Let's see how it looks like. Okay, hybrid pi model. So tomorrow, inshallah, we will primarily discussing this hybrid pi model, and we'll see the formation of this model because it contains the capacitance. So, and the effect of frequency. Okay, students, this ends our today's session. If you have any question, just post in the WhatsApp group.